Hi, I'm Garrett Springer,
I'm Emma Montgomery.
and for our ECE 3710 final project, we designed a trash can with an automatic lid opening system. This trash can has two different components that detect motion and will open the lid automatically when motion is sensed. During this video, we are going to talk about the challenges that we faced while designing this, each of the components and how they're interfaced, and the software that we wrote to get this project to function fully.
So the hardware we decided to use originally was, we ended up just using the stem board we've been using all semester. We used two different motors. We used a push button, then we used an ultrasonic sensor, and then we also used an IR beam. So our first thing we wanted to accomplish with this is we didn't want the sensors to go off unless we put it in the on position. Currently right now it's in the off. So no matter what I do in the front of the sensors, won't do it. But the second I click the button on, it starts to move our motors in the out direction. Then it closes again. And then I can also then use the other sensor to create it to open the lid again. And then if I click the button off again, doesn't do it again, and take off the lid to grab your trash and then put it back. When the power's on or off, we just ended up doing a normal push button. So how it essentially works is it sends out a frequency at a frequency that humans can't hear, and then once it hits something, it sends it back. And with how we had it interfaced with the code, you have to be within a certain distance before it actually sends the signal to start the motors. So it uses infrared light to track if between the transmitter and the receiver is if they receive it, and once the second I break the beam, it sets off the thing. Our reasoning by putting the IR sensor down here compared to up at the top is we want the user to be able to put in their foot and have the lid open, say if their hands are full of trash. So one of our biggest challenges for the project was trying to get our motors to work. So initially why we also went with the design of it swinging out rather than vertically up is we were worried about the torque of the motors, and even with doing the simpler mechanism of opening, we still struggled with getting the torque to do it. So we actually ended up having to change our lid design to make sure we could actually get it open. Our other big issue was with our 3D printed mounts. With how they are mounted to the stand itself, we couldn't get it properly where it wasn't catching on anything or getting the motors exactly lined up with each other, since they're at different heights in the same stand that's printed. Sonic has 4, the IR has 5 different wires, so with there being so many wires to keep track of, it became a struggle with making sure, is everything getting the correct amount of power, or is everything connected to the correct pin? Like one of the biggest issues we had was trying to get our motors to run at the same time, and we discovered it was we had to raise the limit on the current to make sure it would actually work, because when the current was set at the normal amperage, it would not open until we pushed it up, so it's pulling a large amount of current.
The first function that we have in our file is the main function. Main spreads from lines 15 to 62 and starts by calling init, which is a function that initializes both the inputs and outputs of the system, as well as all the clocks that are used. After init is called, we enter a while loop that won't end. This while loop will be operating as long as the system has power. In this function, it checks if there is any input from the ultrasonic sensor, and if there is anything within 4 inches of that sensor, it calls wind, which winds the motors. After that's completed, it delays for 8 seconds, which we decided is the optimal amount of time for this trash can to stay open, and then unwinds, which closes the trash can lid. It also checks the beam brake sensor to see if anything gets in between the two sensors, and if it is, that same wind and unwind protocol is followed. This will continue for as long as the system has power. Lines 64 to 83 contain the pulse function, which controls our ultrasonic sensor. It starts by sending a 10 microsecond pulse to the trigger pin, which tells the sensor to send out the frequency. Once this goes out, the echo pin on the sensor goes high, and it only goes low once that frequency that it sent out after the 10 microsecond delay returns. The two while loops on 71 and 73 check that the echo pin goes high and then waits for it to go back low. While it's high, a counter increments, and then is later used to calculate the total time in microseconds that it took for that frequency to return to the sensor. That amount of time is then returned to the main function, where it is calculated to find out the distance that the object it sensed is. Lines 86 to 105 contain the init function. In this function, we enable our B clock, and it controls our modder, O-typer, and pup doctor, which sets all of our pins' inputs, outputs, push-up, and pull-down settings. We also enable the HSI, which is a 16 megahertz clock. We decided to use this clock because it best suits our needs for calculating the distances measured by the ultrasonic sensor. Lines 109 to 123 contain the wind function. This function utilizes the motors to open the lid of the garbage can. It uses micro-stepping by sending a high signal to each of the two motors' pins in an alternating function. That all is done in the for loop from lines 112 to 117. Immediately following our wind function, we have the unwind function, which works in a similar way, but is used to control the closing of the garbage can lid after the delay that the garbage can lid is open. The last two functions in the file are the millisecond and microsecond delay functions. While they look simple, they prove to be one of the biggest problems that we faced while writing the software. We needed these delays to be as accurate as possible, and they required a lot of fine-tuning using the oscilloscope.
So we were able to actually accomplish all of the goals we had for the project. We were able to create a system that had to be in the on position with using the button. We're able to have it the lid automatically close once it's not detecting any input from either the sonar sensor or the IR sensor. And we're able to also interface them together without them interfering with each other. And the last thing we were able to accomplish was being able to remove the lid, grab out the trash, and then be able to replace the lid and it still work once I click on the on button.
Thank you.